Okay, we have done integration, and we have done the integration by partial fraction, where we have done the two cases, cases 1 and 2. In the case 1, the factors in the denominator were linear, and in the first case, it was not repeated, but in the second case, it was the linear and was repeated. So now we are doing the third case, where the factors in the denominator are linear and irreducible quadratic, but quadratic factors are not repeated. They are not repeated, right? So each irreducible quadratic factor, like ax square plus bx plus c, where x power 2 means it's a in power, is not 1. So it's a quadratic that occurs exactly once in the denominator. There will be correspond a partial fraction of the type. It would be ax plus b. Over here, when it is a quadratic, we will write ax plus b. But when it was linear, we were using only a or b, right? So, and it's divided by whatever that factor, quadratic factor. Okay. I think you will get the more clarity if we will do the some questions. Let's start with find integration of x cube minus 5x upon, or is divided by x square minus 9 and x square plus 1 dx. We can easily see they are the quadratic. Now we will solve it. First of all, what we will write in this way. X square minus 9 and x square plus 1, which is equal to a upon, as we know, x square minus 3 square. We can write it x minus 3 and x plus 3. You want to, first of all, want to simplify it? You can simplify or directly if you are able to. Then a upon, it would be x minus 3, or better I will first of all simplify. It would be easy for all. X cube minus 5x upon x minus 3, x plus 3 and x square plus 1. We have seen it, we have simplified it in this, in the linear, and this is quadratic, right? Whatever the linear is, we will write a upon, as in the previous questions we have seen, whenever it is a linear, we will use only one. One of the factors only, or one of the constant, plus b upon x plus 3. Plus, now it would be cx plus d. I told you, whenever it is the quadratic, for the quadratic, we will use this. Ax plus b upon whatever the quadratic equation is. And these two were linear, so we have used only a and b. But in this case, when it is x square, which is quadratic, we will use cx plus d divided by x square plus 1. I think this point is clear. Now, if we will take the LCM, it would be x square minus 9, x square plus 1. And when we will solve it, it would be a x plus 3, x square plus 1, plus b x minus 3, x square plus 1, plus cx plus d. It would be multiplied by x square minus 9. I think you are getting the point. X square minus 9, x square plus 1. We have seen this will be cut, and then remaining is x cube minus 5x equals to a x plus 3, x square plus 1 plus b x minus 3, x square plus 1 plus c x plus d x square minus 9. Please solve it along with me. You will be able to understand it clearly even better. Now we need to calculate the values of a, constant b, constant c and constant d also. How we can solve it? By substituting value x, let the x be 3 by solving it. Let the x be 3, let x be minus 3. From this we have calculated minus 3, and from this 3 keeping it 0. Then x equals to 0 and x equals to 1. By this we will be able to solve. Now let if x equals to 3, then put this x in this equation. It would be 3 cube minus 5 to 315 a 6 10 plus b 0 plus 3c plus d 0. It would be, solve it, 27 minus 15 equals to 60 d. A seems to be, a is 1 upon 5. Now if x equals to minus 3, in that condition minus 3 whole square, no sorry, cube minus 5 minus 3 a minus 3 plus 3 minus 3 square plus 1 plus b minus 3 minus 3 minus 3 square plus 1 plus c minus 3 plus d minus 3 square minus 9. Solve it. Minus 27 plus 15, 0 for a, plus b is minus 6, 9 plus 1 plus, it would be 0, comes out to be minus 12 minus 60b, b comes out to be 1 upon 5. Right? Now, if x equals to 0, 0, it would be 0, because x will be 0, 0, a 3, 1 plus b minus 3, 1 plus d minus 9. It will be 3a minus 3b minus 9d. Seems to be. Put the value of a and b from here. This and this. Keep these, get this and this value here. You will get it. Solve it. You will get d equals to 0. Right? Now, if x is equals to 1, now solve for it. 1 minus 5a 4, 2 plus b would be minus 2 plus 2 plus c 1 plus d. It would be minus 8. Multiply minus 8. Minus 4 equals to 8a minus 4b. I'm solving it fast for you. 8d. I'm keeping the values for a, b, c. Substitute those values and you will get it 8 by 5 minus 4 by 5 minus 8c minus 8 into 0. Solve it. You will get c equals to 3 upon 5 would be your answer after solving it. Right? Now, substitute all these values in this one. Right. I think it's clear. Now, let's put the values. X cube minus 5x upon x square minus 9. It was x square plus 1. Seems to be 1 upon 5. X minus 3 plus 1 upon 5 x plus 3 plus 3 upon 5 x upon x square plus 1. Right? Now when we are integrating it, x cube minus 5x upon x square minus 9, x square plus 1 by dx. With respect to dx, we are integrating it. 1 upon 5 would be outside, and it would be 1x minus 3 with respect to dx. 1 upon 5, 1 upon x plus 3 dx plus 3 upon 5 root x upon x square plus 1 dx. Right? We can see, I think, integration of it 2x, if we can make it 2 over here and 2 here, it will not bring much change in it. So it would be 1 upon 5 log x minus 3. 1 upon 5 log x plus 3 plus 3 upon 10 would be log x square plus 1 plus c. You can solve it by the proper integration. We have done previously how to solve it. You can solve this. Okay, we have solved this sort of questions previously. So directly I have done it. Even we have done the formula. Okay, I can write 1 upon 5 as outside. I can write it. It's a plus sign. It means it can be multiplied. X minus 3 and x plus 3 again is becoming the same. Log x square plus 1 plus c. I can write it down 1 upon 5 log x square minus 9 plus 3 upon 10 log x square plus 1 plus c. So this is your answer. Clear, and it's easy. Now we are coming to the case 4, where the factors in the denominator are linear and irreducible. Linear, right? And irreducible. Quadratic, and some of the quadratics are repeated. In our case 3, the quadratic factors were not repeated. But in this case, quadratic factors are repeated. Right? To each repeated quadratic factors like ax square plus bx plus c, which is in power r, it means it's repeating r times. There will be corresponding a sum of r partial fractions of the type. It would be like this: a1 plus bx upon 1, then a2 plus b2x upon, which is power 2. If it is repeated r times, then it would be r times, and like this. I think you will understand better if you will do the question. Okay. Now let's start with evaluate. We have to evaluate this question. 2x4 plus 9x square plus 8. We can easily see the denominator. In denominator of the given, it's better to write this in the exam also. In the given integral contains a linear factor. A linear factor which occurs exactly once and an irreducible quadratic factor which occurs twice. Right? So we can say 2x power 4 plus 9x square plus 8, which is divided by x square plus 2 and square. I can write it down a upon x plus, it is a quadratic, it would be a bx plus c, and it would be divided by quadratic factor once, then plus dx, because a, b, c, now d plus e, because these are the constants, better to be in continuity. It would be x square plus 2 with the square, because it's twice. If it had been 3, If it would have been 3, then we would have added fx plus g upon x square plus 2 power 3 and so on. I think it's clear. Now, it would be, let me solve it. We all know we will take the LCM and then it would be cut. So I'm doing it directly now. 2x power 4 plus 9x square plus 8, and over here it would be a multiplied by x square plus 2 whole square plus bx plus c would have been multiplied by x and plus 2 plus c, sorry, c is already there. It would be dx plus e would have been multiplied by x. Now open it and solve. It would be ax power 4, because when we solve it, I'm writing it here, x square plus 2 whole square, it would be x power 4 to the 4 plus 2 to the 4 x square. This is right. So this is open. When we open it, it would come like this. So I am solving it directly. Okay. X power 4 plus 4x. Let me use the black ink. This would be 4x square a plus 4a. Plus it would be b x power 4 plus 2x square b c x power 3 plus 2xc plus dx square plus ex. You will solve it. If you will simplify and solve, it would come in this way. It would be a plus b. I'm solving it. X power 4 plus cx cube plus 4a plus 2b plus d x square, because all of the same term I'm using it together. X square, wherever it is square, I'm using them together. Right? Then 2c plus f is e. E is x plus 4a. Now, thing is, over here we have 2x power 4 plus 9x square plus 8. What we will do is, now to solve it, we will equating like powers. Powers of x. X की powers we will equate. Like x power 4, over here x power 4. Means a plus b is equals to 2. Because x power 4 would be remaining same, and whatever the remaining coefficients, that will be equal. We can say 2 equals to a plus b. We can say c is equals to 0, because there is nothing like x ki power 3 is not there. So c is equals to 0. And when I talk about x power 4, this thing will be equals to 9. 9 equals to 4a plus 2b plus d. And in the x, there is nothing like x here. So it would be 0 equals to 2c plus e is equals to 0. And 4a, it means 8 equals to 4a. Now, when we solve these equations, we will keep the values over here, and there. We solve it, we get it. Solving these we get a equals to 2, b equals to 0, c equals to 0, d equals to 1, and e equals to 0. I think it's clear. Now we will put these values, substitute these values in our equation. Which one? Which equation? In this one. I think it's clear. It's easy also. We can solve it because the same method we are using it. X power 4 plus 9x square plus 8 divided by x square plus 2 whole square equals to a is 2 upon x plus 0 upon 0 is become 0. This whole will become 0. As b is also 0 and c is 0. b is 0, c is 0. So it will 0. In d, e would be 0 and d would be 1. So it would be 1 into x is x upon x square plus 2 whole square. I think it's clear. Now we will integrate it. 2x4 plus 9x square plus 8, because this was the question. X square plus 2 whole square. With respect to x, it would be 2 would be outside, integration of 1 upon x dx plus integration of x upon x square plus 2 whole square, that is dx. When we solve it, we will get 2 log x plus half let me multiply by 2 both the sides. Then half, it would be x square plus 2 minus 2, let it be 2x dx. I think if you will solve it, you know how to go ahead. You will get it. 2 log x. I think by this time you are expert in integration. It would be x square plus 2. It would be minus 2 plus 1. Let me put it this way. Minus 2 plus 1. It would be, by substituting, we have done it. So it would be 2 outside. And we can get 2 log x plus half. Because it would be, it would be minus. Because from here we will get the minus and we'll bring it outside. It would be x 1 upon, we can keep it x square plus 2. Because it's minus 1 plus c. This will be your answer. I think it's simple and easy. Let's talk about a little bit about the definite integral. I think now you are comfortable with the integration by partial fractions. We have done all the 3 techniques of integration. Integration by substitution, integration by parts, and integration by partial fractions. And all the 4 cases of integration by partial fractions. Now, definite integral, let fx be any antiderivative of fx. Then for any 2 values of the independent variable x, say a and b, the difference fb minus fa is called the definite integral of fx from a to b and is denoted by like this. Integration, just give me a second. Integration, integration fx from a to b. Thus we can say integration हम a से b तक limit जा रहे हैं. fx, we will do it with the graph and all other questions. dx, where we can say function, well, if we integrate it, it would be the antiderivative, but it would be fb, where b would be the upper limit and f minus fa to the lower limit, where a and b are called the limits of integration, where a is the lower limit and b is the upper limit. First of all, we will write with the function fb minus function f with a, right? Or we get, this is the way, or even we can write it in this way. Sometimes we write it simple and a and b. Let's do some questions. You will get more clarity and I will explain you better. when we are integrating from 1 to 2, means lower limit is 1 and upper limit is 2, x dx. How to solve it? Simple. It's a, integration is simple. First of all, we'll simply integrate it like x2 over 2. The way we do it for x. And then we will say it's from 1 to 2. Now we can say, keeping the value of x to be 2 minus keeping the value as the lower limit 1. It would be 2. It will be 3 by 2. Is clear? Now question number 59, where integration of 1 upon 3x plus 2, where is coming from 0 to 1 upper limit. Simple integration करेंगे first of all. It would be log 3x plus 2 and it will be divided by 3. We have already done this type of questions and we have done the formulas also, special formulas for this. 0 to 1. Now we will put the value of x as upper limit and subtract it and then the limit of the lower limit. It would be 3, 1 plus 2 upon 3 minus log 3x would be 0, your lower limit, plus 2 upon 3. It would be log 5 upon 3 minus log 2 upon 3. We can take the 3 common, log 5 upon 2 as it's subtracting, so means it's a division. Clear? Now, when at e power 2t dt, we can write it e2t upon 2 इंटीग्रेशन सिंपल इंटीग्रेशन ऑफ ई अगर e2t का इंटीग्रेशन बोला था तो आपका e2t अपॉन 2 था राइट तो सेम थिंग वी हैव डन इट हियर हमने इसका इंटीग्रेशन निकाला है बस हमने डेफिनेट इंटीग्रल है मींस 0 से लेके 1 तक के बीच में सपोज वी से e पावर 2 minus e power because t की value we have kept it upper limit minus e power 0 2 से multiply we have 2 multiplied by 0 will be 0 upon 2. We can say half e square minus 1. That's the answer. Now let's do some properties of definite integral. Here, if integration of fx is leading from a to b, it means if some other function f t to dt is a upon b is also same. That is, the variable of integration is dummy variable in the sense that any other variable produces the same results. Right? For example, if we say 1 to 2 x dx equals to, which leads to 1 to 2 dt upon dp. If they are getting the same results, means 3 upon 2. Right? Now, second property is saying if is a to b and the same function, we can make this function can be the lower limit can be the upper limit and upper limit over here can become the lower limit only by putting the sign minus. Means interchanging the limits of integration changes the integral sign. Right? Like this. Example 5 minus x dx where lower limit was 2 and upper limit was 0. And when we change the sign, we made the lower limit to be 0 and upper limit to be the 2. We simply put the negative sign. Second property is when we have a to b, integrating from a to b, some function, then it may be some other one more factor will be added, a into c function plus, now it would be from c to b. Whatever is upper here will be the lower limit so that it can be same, a to b, right? Where c is in between a and b. That is the interval over which a definite integral is to be evaluated, may be subdivided. We can subdivide the, right? Now, fourth, geometrically, a leads to b with fx can be interpreted as the area of the region bounded by the curve of the function f, xy and x-axis and the lines a and b. हमने जब whenever we have said कि a और b के बीच में है हमारा जो भी फंक्शन है ना fx का वो हमारे दो लाइंस के बीच में है a और b की लाइन में हमारा x वैल्यू जो है, इसमें जो x है, x एक्सिस पे हमारी जो लाइंस बनेंगी वो a एंड b की हैं। सिमिलरली अगर हम g y कह रहे हैं, dy के रिस्पेक्ट में ले रहे हैं, in that case the area of the region bounded by the curve is where y axis and the lines y is equals to c and cy equals to d. It depends upon how we are taking. Let's take the example. There is a graph where is x-axis and where is a y-axis from 0. Over here function is y equals to fx. Then we will say y equals to fx. Fx means a, and we are asking to calculate this area from integration a to b, and the function is fx. In that case, it would be on x-axis, a and b. This is the bounded area, this wala area. This area will be, and this, if this is a curve for this y equals to fx, wherever it is AB, is saying this area is your integration, which is a definite integral, right? When we are saying is gy with respect to y, in that case, an integration c to d, then c and d would be on the y-axis. This area, I think, is getting clear. Okay, let's do one question. Use definite integral to find area of the region bounded by the curve y equals to x in modulus. The x-axis and the two lines are x equals to -2 and x equals to 1. What they are saying? Let's draw the curve. It's like this. I suppose this is x-axis. I'm making the y-axis. It would be 0. And I'm saying x is equals to 1 somewhat here. It would be 2. It would be -2 will be somewhat here. It's saying modulus means y is equals to 2 means it would be always plus. Is 2 I am taking it as 1. Graph would be like this. Right? It would be 2, it would be 1 for y-axis. X, as it is y is modulus x. Right? I can say x modulus minus x bhi aata hai when x is less than and equals to 0. It can be plus x when x is more than 0. If x value is more than 0, then it would be x, and if x value is less than 0, then it will be minus x. हमारा required area क्या है? Required area is -2 to 1 modulus x dx. It's asking us to solve it this way. Can we write it? -2 0 x dx plus from 0 to 1. I've used the property, this property by subdivided property. This one. A to B means A to C and C to B. Here, what I have done is -2 to 0. It was, it was -2 to 1. So I made it from -2 to 0 and then 0 to 1. It becomes like -2 to 1 if we add. Can we say -2 0? This would be minus x. Why it is minus x? Because I told you when the value, if x is less than 0. Or where is less than? Because lower is upper limit is 0. So answer would be minus x. Plus, it would be 0 to 1. That is, x is more than 0. It would be plus. Some modulus. Modulus means in that, which I said by definition it is. Right? So it would be minus x square upon 2. We have kept it in definitely -2. Plus it would be x square upon 2. Simply we have integrated and we have kept the positive. this definite integral. Now value would be 0. First of all, we'll get the upper limit upon 2 minus 2 square upon 2 plus it would be 1 square upon 2 minus 0 upon 2. We will solve it. It would be minus plus 4 upon 2 plus half. It would be 5 upon 2. Whatever square units. Why square units? Because area. So we can say the area, this area, whatever is required, this area is 5 by 2. I think it's clear. Okay, let's do the last question. Find the area of the region bounded by the curve y equals to x square, where the x-axis and the lines x equals to 3. Simple. If I draw the graph, it would be like this. Let it touch here. It would be 0 and x is saying 2. Let it be 3. Then they're asking about this area. And this equation will be x square. Right? This is y and this is x-axis. Now area, they're asking me to calculate for 2 to 3 x square dx. I can solve it easily. 2 to 3. It would be 3. I have put it 3 here. It would have been 2 is 3. Is equation from 3 to 2. Now, keeping x equals to 3, power 3 upon 3 minus, now keeping x equals to 2, power 3. Answer would be 19 upon 3 square units. I think it's clear to you all. And by this, we have finished with the basics of integration. In the next session, we will talk more about the applications of the integration. But I will suggest you to revise them in the all the videos related with the basics of integration. Because these things or these questions, whatever we have done in it, would be used in the applications. And over there, we will not spend much time how to solve for the integration. Right? Directly, I will tell you the tricks and how the methods and how to apply them in the business and the